Cool. So first I want just want to check in. Is everything, can everyone see the code clearly? Everything good? Cool. Nice, nice. And all this should be available on the GitHub page, which was in the email that I sent out earlier, if you want to follow along. But so optical character recognition, or OCR for short. What is it exactly? So I'm not an expert. From my understanding, OCR refers to a whole general suite of different types of software that all attempt to analyze. Thanks. That all attempt to analyze images and turn images, specifically what's in the images, into something that's machine readable. So it could be words. Sometimes it could be words. It could be numbers. It could also be. I'm sure there are cases in which you turn images as well into something that's machine readable and something that we can actually use and analyze in our data. So at the moment, how I've been thinking about it is it's a sort of data cleaning tool for us. That's one way that I've thought about, to turn images that we might use in our data, we might use as where it has raw data, into something that's we could actually analyze in an Excel spreadsheet or in a CSV file that we could put in R or in Stata or something like that. And so I will say that there's a lot of different types of OCR software out there. Some of it's open source, some of it is proprietary that you have to pay for. But the one we will be using here is something called Tesseract, which founded many years ago, but I think it's now managed by Google. It's an open source software, and I think it's one of the most popular open source OCR packages out there. But I believe that there are others out there that you could look up on your own. So all of this is in R because there's a lot of wraparound functions here. And so I'm just going to import these packages basically. Tidyverse for data science, string R for text manipulation, Tesseract because Tesseract is basically the OCR package that we'll be using here. This other package called Magick, which I didn't know about until recently, but apparently there's an open source software called Image Magick that's not specific to R. It's specific to a lot of other programming languages as well, but it refers to a whole suite of a whole package of ways that folks have used in other programming languages to upload and edit images that apparently you could do in R and you could do in other packages as well. There's a lot of flexibility that we're working there. If you're a little bit confused on how the heck we're gonna work with images in R, you will see in a little bit. It's actually quite simple. So we're gonna import all those packages. I'm gonna run my working directory. I'm gonna run this function as well. I won't go over these specific functions in detail, but basically this is code that I got from someone else a long time ago, which basically splits text data into something that's that we could work with into a CSV format, which you will see in a little bit how this works. But we don't, for the purposes of this workshop, we don't have to go into it right now. But if you want to in the future, you could just look at this code, which I have a lot of comments on. And so I've also provided a couple of links to, let's see, to these R documentations on Tesseract and Image Magick, or the Magick package. So in your own time, if you want to take a look at other features of these packages as well, I've linked them over here as comments. So in terms of the images that I'll be working with as examples here, y'all can see these images, right? Cool. We're not going to look at them all, but basically the product that I was working on was I was basically web scraping COVID-19 infection rates in prisons from state websites. So a lot of different states had their own way of reporting COVID-19 positivity rates and deaths in prisons during this period where COVID-19 was when we didn't really know about COVID-19 back in early 2020. It's hard to believe. So like every state had its own way of reporting a lot of this data. Hawaii had this, Indiana had this, Kentucky had this, like, so you could, all these are basically images that they just posted on their website. And one of the things that the team I was working on were interested in doing is turning a lot of these images into actual like CSV machine readable data that we can actually use in Excel. So that's like one sort of data source that one data source where OCR can be useful. In that like something that's basically images that are not machine readable, but it's formatted in a way where you can theoretically where it looks like it could be in such an easy way. You would think that these states would upload data in a machine readable format, but they don't, probably for many political reasons, also making it harder for a lot of researchers to access data as well. But I think we'll be working with, so those are the images that we'll be working with here that I've tailored all of this to. So our goal right now is to kind of turn some of these images into like machine readable CSV files. So that's our task right now. So Magick, basically, the reason why we're using Magick and importing the Magick package here is that it allows us to easily read images like that. This one code right here, image read, basically reads that image into, it assigns it into this variable. And I believe I'm not an expert, but it looks like it's a pointer to a specific image object right now is what this is doing. And you could just, if I type in this code, you could easily just like any other like data set that's assigned to a variable, you could just export it into, you could just type it in, export it into the console, and it'll spit out two things when you output into the console. One is this image that you see of the actual file, pretty cool, in the viewer. Typically, this is where like the graphs, I think, in R would be posted. But apparently you could do this with images as well. The other thing that I'll note that gets outputted into the console at the bottom left here is basically a data file that tells you the format, the width, the height, a lot of other details as well about the actual file. And this is very useful, especially if you want to crop the images, if you want to take away some images and break apart this image into parts that you want to work with in the future. And I'll show you how to do that, because it shows the width and the height of the image by like the number of pixels as well. So that's something to keep in mind. So what happens if we actually just apply OCR to this right away? Like, okay, we don't want to do any image editing. Let's just apply OCR. Literally, you could do this with one line. It'll literally read the image and try and output all of this into a string. So this here, it might take a second. And then we can take a look at the string output. It literally just read this image and outputted a string. It's just one string file, which is hard to read, but we could put it into, we could output it into specific lines, basically. And these functions right here, I took from the string R package, which is a package that we use in R for text analysis and text editing. And so when we look at the actual output in string and compare it with the images, you start to see some issues that's going on here. There are some good things actually, because it read I suppose it read, quote unquote, a lot of these institutions, these facility names, names of prisons very well, actually, like Kentucky Correctional Institution for Women. You can see that it actually works. But what it doesn't seem to do a really good job with is distinguishing between what are letters and what are numbers, because it seems to be there's an issue here in that it's not reading some numbers correctly and whatnot. But we're working with something that seems to have some use, basically. So with OCR, I believe what is probably the most important factor, like, is trying to edit the image in a way where the software can actually read it correctly. And so what ends up happening for me that I found is that a lot of the time I spend a lot of the time just like editing the image in different ways. And so for the most part, we're going to be using image Magick to begin editing this image right here into something that we can actually that OCR would actually pick up on. Image Magick has a lot of different packages. One of which is this package one of which I will use here is to turn it into something called the Grayscale. It basically converts the image and converts colors into black or white scales, a grayscale basically. Because OCR, I believe, can only really read black and white pretty easily. If you notice from the string output here, it didn't read the institution, the staff. It didn't read the top row because the top row has like a black background and a white letters. So it apparently doesn't read it that well, it looks like. And so there's a lot of functions like image convert, which converts images into a grayscale. So it turns different colors into various gradients of black or white. There's also this other function called image threshold, which forces colors into black or white that set a threshold value. For instance, if I just set a threshold value of 60%, it literally turns every pixel into black or white, basically. And so a lot of these are just various ways to edit the image. Another thing that we could do that I'm just going to type here. Another thing that we've noticed in this image is there is a lot of black lines that we see. And sometimes these black lines we just don't want. And it took me a long time to figure this out, but apparently you can just edit out the black lines that you see here. It's through a function called some sort of morphology, which seems to be, for me, it seems to identify various shapes in your image. It can identify circles, it can identify ovals. In this case, I've set it to identify specific rectangles. And so running this code, I know it may be a little annoying and it may be hard to follow, but I think as a rationale, basically what I'm doing is I'm identifying specific black lines in this image using this image morphology function. And this image negate function as well, which switches up colors basically. So if I run this image H lines, you'll see like what I've done here is identified a bunch of rectangles, but I've also identified various where the locations of where the lines are located in the original image. And so I then apply this image composite function onto the original image. Again, I'm assigning everything into like a variable. And right now, I've taken out the actual vertical lines, which is great. Apparently that's something you can do, which is pretty cool overall. And now we're starting to get a picture that I think is looking a lot better here for applying OCR. And then we can also crop out specific parts of the image using, aptly named image underscore crop on an original image. And this is where I think this output at the bottom becomes super useful, because you get to know, you can type in the x-axis and the y-axis, and then from there type in how much you want to crop. So in this case, I'm cropping the top of the image by 50 pixels. So this top area will disappear, which I will apply right here. So you can see in the image right now, I've taken away the top part because it's something that I think is just, we don't need. And now it's starting to look a lot better. Ultimately, this image, a lot cleaner. We don't have various lines. So let's try and apply OCR now to see if it becomes better.
Hey, Todd, a quick question on
Yes.
how you cropped the 50
Yes.
pixels.
Yeah.
Can you just kind of talk through where that is in the code?
Yeah, it's right here. So I would say like a lot of these functions, if you want to slow down yourself, you could use a question mark, and then you could search up in a directory and documentation what everything looks like here. But are you asking about like the meaning of
yeah, like it looks like
function?
you're adding 50, but it was actually cropping.
So I don't fully understand it, but basically this basically how it's set up is it reads this second part reads a this function has like basically you give it a string and it reads this first part as the x-axis, the second part as the y-axis of your image. So as we know from previously, because we know like the image that we had previously had a width of 1,340 pixels and a height of like 838. And I think adding these additions, what they basically mean is, I believe what they're communicating is that they're telling this function to crop out this number of pixels from the original image. I'm not sure why it's not minus and why it's plus. That's probably has something to do down here in the documentation that I'm not completely sure about. It's just something that I copied below. And it looks like there's a lot more ways to resize it. Like, yeah, as Kyle was looking at here, I would say like a lot of this you could get from the actual documentation that you could get at. So there's a lot more here that's hidden, but apparently what this basically means up here, this addition 0, addition 50, is I'm keeping the x-axis the same. So I'm not cutting I'm not cutting the width of the pixels. I'm just cutting the height of the pixels by 50, which removes the top. So it's confusing, but that's apparently how I read it from the documentation. So now we have this amazing image, and let's apply. So we applied the OCR. Let's look at it now. So it's slightly better. You know, the facilities on the left seem to be pretty good, but we're still running into the difficulty of this OCR not reading numbers correctly, basically. It is a little better though, which is good. So one thing that we could actually do to improve the software a lot better is that Tesseract has a lot of you could actually apply various settings to the OCR and Tesseract, basically. So you could actually give instructions to the OCR function that you only want it to read numbers, or you only want it to read words, or you only want it to read specific characters. And I think Tesseract could also you could apply it to a lot of different languages other than English. So I would say that there's a lot of settings to tinker with, not only on editing images, but also on editing the software in which you apply the OCR to an image. If it's a little confusing, we'll see in a little bit. Well, first, I'm just going to run this function, which basically just gives us gives us all the facility names. So right now, what I'm doing is I'm separating the facility names from the actual numbers that we're working with here, that are on the right side. So what I was getting at here is that you could actually set the Tesseract engine to restrict characters. There's a lot of other settings as well that you could probably look at in the documentation, but because we're just looking at numbers, we could literally create a Tesseract, an engine, where it only reads, for instance, well, first you could read here, I set an engine called and assign it to a variable called numbers only. It's in English, and I've set the option of only whitelisting or only assigning Tesseract to look at numbers from 0 to 9. Something you could do. You could set it to other characters as well. So right now, we can apply the OCR, but set the engine to numbers only. So it's only looking at numbers. Assigning string output, then turning it into lines. Now let's look at the numbers output. And looking at below here, it actually looks a lot better now. Now that it's no longer having these other characters, but it's just focusing on numbers. And you could, if you look on the right side of this image, there's also some asterisks that we could add on if we wanted to. That's just extra information that I've just ignored. So the numbers actually look pretty accurate. Now I think the hard part is putting all this together. And that requires a little bit more code for us to work with here. And I think this is where, I guess you don't have to know what's actually going on here, but all the details, but literally what I'm doing here is I'm putting, I'm separating a lot of these numbers, a lot of these out at the bottom. I'm splitting them based upon the space, because you could see like, this is literally just one string, 1001, which refers to your first row. And so something that we could do is literally separate everything out by space and make each of these like their own separate column, which is done here by calling this function. I'm also going to set column names so we know what these are. And so I ran this function, and we don't have to know the specifics, but literally what it's doing, it's separating everything out into, let's actually run this again so we can see the whole column. It's literally separating all of these strings out from above into actual rows we could work with here. So that's pretty cool. Just looking at this right now, already we're seeing a problem actually, because it looks like for whatever reason, the OCR is not reading this row's character. So instead it assigns this to an NA. Apparently it's not reading this 3 correctly, which is really infuriating. That's, I think, one of the drawbacks of OCR, to be honest, that like sometimes it just doesn't read everything correctly. And I think there are probably ways to edit the image. Maybe we could make various shapes more like, I don't know, more bolder. That's something that you could do, is to like make these letters a lot bolder. I haven't figured that out yet, but that's something you could apparently do with image magic. But you know, barring that, it looks like a lot of this data is still pretty good. So we could literally just add on to the other data that we have on the names of prisons, and filter it, and apply some other filtering functions, and voila, we converted this image previously into something that's more machine readable. And this is something that you could literally output like with write CSV or something like that into a CSV format. You can also view it as well, OCR data table. Yeah, something that you can output, that you could actually do. And I think for the most part, this one is pretty accurate, aside from the 3 it's not reading. Okay, so that was a lot that I threw at you there. I've also provided another example of, in this case, Indiana, which will mostly just repeat what we've like mostly just repeat like the instructions that I've set out here on applying it to the Kentucky prison system. I will show you one little thing though, like some just highlighting things you could do in image Magick, for instance. I'm just gonna import this image, and then we could probably break out and talk about the utility of OCR in our own research. So let's look at the Indiana image. It's a lot more complicated, as you can see here at the bottom right. There's a lot of colors, there's a lot of lines. The some rows have like a gray background, some lines are just white in the background. So there's a lot to work with here. And you can imagine it'd be very terrible if you applied OCR right away. But there's a lot of ways in which we could edit the image, for instance, which I'm just going to show a couple ways to do this. For instance, we could crop the image, which I've done here. Like I've cropped out the top part so we don't have to worry about that. Kind of, we already know the names of the columns that you could just type in yourself, set yourself when you create the data. You could do something called negate, which basically negates the colors. This is what I was doing previously a lot earlier with identifying the various lines, vertical and horizontal lines. Then we could convert this into a grayscale. So it becomes like this. We can apply an image threshold. I've set the threshold to 45 because I was tinkering with it. Apparently that seems to work the best. And then we could turn it into something like this, where it's a lot more clearly something that's black or white. And finally, we can negate this again. So it could be something that's a lot more machine readable. Now this is something where we've taken out a lot of the color and taken out a lot of the noise that would interfere with OCR. And then you can remove the black lines as well. There's not only like vertical black lines that you can identify, but you can also identify horizontal lines as well. So let's just run all of this. So you get to see like the output itself. And then, so we've taken out the horizontal lines. We could also take out the vertical lines. So, you know, looking at this image, you see it's a lot better now to read in OCR format. I will say when I applied OCR to this, it wasn't really accurate for a lot of reasons. It didn't read these numbers correctly. You could take a look at it on your own time, but I think ultimately the rationale is the same. A lot of what I'm doing here is I'm taking images and I'm cleaning up these images in a way that the software can actually read correctly. And if there are any other issues, what you can do is to apply a different number of settings to the actual software itself. In this case, I made it look at only numbers, for instance, but there are other settings that you could look at as well in the documentation. And a lot of these ways you could use to apply the software to have machine readable data. I know, Will, you raised your hand.
Yeah, I was wondering, like, with these sorts of things, and as I was looking at this,
yeah,
do you know about what fonts Tesseract can sort of read, or if there's a way to like tell it, hey, this is like we're looking at Arial or something?
That's a good question. I'm not entirely sure. Yeah. I actually don't know. I'm sure there's a setting out there for it. Yeah, but I think it's set up in a way in which like it could, well, it's set up in a way where it could identify different patterns, and if that pattern seems to align with some sort of letter, it could do that. So I've seen previous examples of it being applied to Times New Roman, Arial, a lot of different formats. I don't know, but kind of that's mostly it in terms of the workshopping portion of this that I wanted to share with y'all. Just things that I've encountered. I don't know if folks had any questions about the software itself. I'm happy to answer them. If not, we could probably move on to like brainstorming some ways in which we could use this in our own research. But does anyone have any questions?
Yeah, I actually have a quick one. Does this allow us to do OCR for PDFs? Because from my experience, I scraped a lot of PDFs, and PDFs being PDFs, sometimes there are images in a PDF, and I wonder if it's possible to use the same kind of toolkit here to do OCR for PDFs.
So there's a section in our documentation, read from PDF files on Tesseract. So the answer is yes. I haven't done this before, but apparently you can do that. Like, so yeah. If you want to turn a PDF into something that's machine readable, you could try that and experiment on your own. Good question. Yeah, Will?
Yeah, so you said that Google is sort of managing Tesseract now. Do you know like what Tesseract is? Like, is this a big package that's sort of has a maintenance team behind it?
Yeah.
Or is this just something that's primarily in Python, then every once in a while it gets thrown into R? Like, what is it?
Other people can answer this because I'm not fully knowledgeable, but from my understanding, it's not specific to a specific like language, but it's a general like open source software. Like, it's one of many different optical character recognition softwares out there. And yeah, Jacob has send you a Wikipedia page on it. And I think it was put together by someone from a company, and I don't think Google acquired it later on down the line. And I'm pretty sure they've been updating it every now and then as well. But there are other sort of OCRs softwares out there. But I think a lot of the ones that are, but a lot of like the languages, I guess in R and Python, there's a lot of packages out there that, apply the sort of software in that language. So it's most accessible, I think. It's good to know. Oh, yeah, it's free software. Yeah. All right, if there are no other questions, we could think about ways that we can apply this to our own research, if there are any. Like, I don't know if you're in your own research, you're working with images at all, and how you would think about this in your own work. So.
I used to have a project. Actually, this was my master's thesis, where I downloaded a bunch of proceedings from legislatures. So in a particular session, people talk, and then I was trying to figure out who spoke what, like on what topic, and like kind of what they're saying. And this is for regional parliaments in European countries, which is my research area. And I remember doing this in Python. It was not that easy. A lot of problem came up because the text was not clean. So I think for OCR with numbers is easier, but if you have something like a proper document, I need to spend a lot more time in terms of text cleaning. Yeah, and that's a major challenge when doing this kind of research. Yeah, one more thing I would say is that sometimes, especially with proceedings like this, they like the 2-column format, but a lot of the OCR software, they don't know how to deal with that.
Oh, yeah. Yeah, I feel like the solution there would be to look at 2 images, to crop it into 2 images.
Yeah.
But yeah.
When I was in undergrad, in my undergrad thesis, I was web scraping a lot of from these internet forums. And I remember in my initial analysis, I noticed that it was just because a lot of people would just post like images, like memes and stuff on these forums. And I just save it as like image.png or JPEG or whatever. And so then in my initial result, when I was doing text analysis, I didn't like clean them or anything. So it was like, there's a huge association here between image.png and like this theme. And it was completely useless, but that was always like one of the top results. So having something like this would have been much more useful in identifying if there'd be some way to direct it to like identify repeating like images. I think that would have been a really cool addition to the project.
Yeah, that's a good point, Jacob. Like one of the things, I mean, one of the things you can do like is you just have a folder full of images, and you know a lot of them are like. So one thing that I've noticed some people doing on social media is that like people take screenshots of tweets and they post these screenshots of tweets. I feel like OCR might be okay with, I mean, if you just applied some basic functions from ImageMagick to like grayscale it, clean it up a little bit. You could just apply OCR to everything, but just see what you get, because you might get some text there as one like first pass to look at memes maybe. I guess one question that I had, I don't know the answer to, maybe Scott, you could chime in, is like, are there packages out, or how useful are like these image recognition packages out there? Because I don't know how useful it would be for a social scientist for like algorithms to identify images and to let us know what picture this is.
Depends on what you're doing, in my opinion. Sorry, I haven't been active. Andy came by my office, so I stepped out for a second. So one area that image recognition software has actually been really useful in my research is captcha breaking. So if you're scraping on the darknet or other websites that don't want to be scraped, they often have flood protectors in the form of captchas, and image recognition can help a lot to be able to automate or semi-automate breaks for captchas. And so depending on the website you are looking at, it can be quite useful if they have that type of protection. Yeah. Those are my thoughts. What else have we talked about in terms of when OCR is useful?
We talked about identifying potentially memes. I think Kyle talked about some like text data from something about politics. Sorry.
Legislatures. So basically like Congress.
Yeah.
Mm-hmm. Yeah, I mean, one of the biggest applications of OCR these days, I think, is digitizing archives. So extracting text from PDFs, but often extracting information from tables as well. And it can become a really tricky process because there'll be these little like disorientations that make it difficult to register where the breaks are, and a 3 will be confused as an 8 and things like that. But I mean, if you can digitize things, I mean, thinking politics right now, that book, Kyle, have you read it, the Hijacking the Agenda book?
I have not.
Have
Sorry.
not. No, you're fine. Their whole thing was they went through like the whole congressional records of all floor speeches and back to like the very first Constitution and did text processing on everything. So they had to like OCR like 250 years of floor speeches, which obviously is like who would want to do that? But once you've done it, like holy crap, I can keep that data. You know, that's cool to tell. So I think if you're willing to do kind of creative thinking about archival sources, it could be great for extracting text from image data.
That is OCR at like reading like handwriting, just because I'm imagining like you're going back and reading like this awful sort of like cursive that's written in 18th century English. You know, it's probably difficult.
Yeah, OCR like love letters between different key influential figures or something. That would be fascinating. I would love to see that.
Wait, so is the answer no? It can't read handwriting?
I don't know, Jacob, have you looked into it or was it just an idea?
It's just an idea. I was just wondering if they're going
Maybe
that
it
far.
could.
I have some church letters that might need analysis.
Might be possible.
I was really hoping someone had an easy answer. And the answer was yes.
I would say handwriting is just so varied, you know, I feel like that it's probably hard to identify.
Imagine companies are working on that. Min mentioned in the chat, like, oh, you want to go, Min?
Yeah, not just Adobe, but I think this pertains to grad students. A lot of workflow / note-taking software is also getting into that. I think it's called Roam or something, but it's like a popular notes application where you just take notes and it'll like seamlessly read your handwritten notes if you're using a tablet or taking photos, and then put it in a text format. I could see how it's very useful if you're, you know, a grad student and you've got a bunch of notes and your handwriting deteriorates over time from stress and, you know, dissertation madness. But then like, yeah, that was the company I was thinking of. But
Because I have like a note-taking app on my iPad and I can search within my own handwriting for certain
oh,
words.
you're already on it. Okay, the future's now. Yeah, it's already happened. I was just like, oh, maybe it's just around the corner, but we don't have to worry about it right now yet. And never mind, it's already here. Yeah.
Here's a well, Will just sent a link for using Tesseract to recognize handwriting, but here's another link that Jay's not here today, but Jay in the past sent me this, which is supposedly quite good for detecting document layout when working with archival sources. So Jenna, that might be a good route or something that would be useful for you. One question I had, Todd, was have we talked about how memory intensive processing image data can get?
No, I do not know about that. I imagine
It
it
can.
Good.
Yeah, so it really depends on what type of image data you're looking at, but for OCR and kind of any image recognition to work quite well, you need to have a certain amount of granularity. And so for fuzzy pictures, the default way to do that is to actually blow up the picture size and then smooth over the pixels and then shrink it back down and do the extraction from that. And so inflating the picture in the first place basically increases the memory demands just a huge amount. So if you loop over a ton of like historical archive or historical documents using Tesseract and Python, what will happen is you'll hit like, it'll be like 3 seconds to process, 10 seconds to process, and then all of a sudden you'll hit a document that takes about 10 minutes to process. And so when you're doing OCR, especially if you're using a very large amount of image files, you need to be attentive to kind of how skewed that distribution can get and the effects it can have on runtime. So often you need to do kind of smaller sample subsetting to kind of get a sense of what the runtime distribution will look like before actually deploying it completely.
That makes sense. Also, that makes sense with the workflow thing because, yeah, because I think one of the issues is that like OCR really does need like really clean data, and smoothing like the edges out of a lot of words helps the software out. So. All right, I think if there's no other thoughts, we could probably end this early. You know, hopefully you've learned that this is something that you can actually do, and if you want to pursue further, there are even more resources out there. And this was a fun project overall, putting this together, because I never learned apparently you can do this with images, you can do this with R, and it's actually pretty simple once like you set things up and think through the workflow. So I don't know when's the next time we're meeting, like in 2 weeks or something?
We actually will be meeting next on March 4th. So this will be